Welcome. All right, so now we're going to be using the description to write equations for square root and cube root, and we're going to start off with square root. So the parent function f of x equals the square root of x is reflected across the x-axis, stretched vertically by a factor of 2 and translated 1 unit up. So we want to identify how each transformation affects the function. So let's underline our transformations. Right, so we are reflected across the x-axis. Stretched vertically by a factor of 2, and then translated 1 unit up. So let's review each of the parts of the general form of a square root or a cube root function. The only thing that would be different is the index would be 3. But it's right here where the little star is, and I do believe I put that in your notes. F of x equals a times the square root of b times, notice the parentheses there on x minus h. Right? You do want to factor out b, otherwise you're really not going to be sure what h is, plus k. A is your vertical stretch compression and reflection over the x-axis if negative. B is your horizontal stretch compression reflection over the y-axis if negative. H is a horizontal translation and k is a vertical translation. And so when we write the equations, when we graph anything with functions, we want to think PEMDAS, just like you solve an equation, except we're going to be thinking of multiplying and adding subtraction. So multiplying, dividing. So multiplying, dividing, if we have any reflections or dilations, right, that's something's multiplied to either our function or to x. Right? So we're going to think about those first, and then the add and subtract, that's the translations. All right, so now let's identify how each of these different actions on the parent function affect our parent function. So let's take a look. Identify how each transformation affects the function. A reflection across the x-axis. So if we have a reflection across the x-axis, a is negative. If it was a reflection across the y-axis, b would be negative. We're vertically stretched by a factor of 2. So that's affecting a again, because b is horizontal. And we have a translation 1 unit up. All right, so let's identify all the parts of our equation, and then we can just plug in. So we're going to identify a, b, h, k. You'll always have something you can write in for each one of these. Sometimes it's a 1. Sometimes it's a 0. A and b, by the way, never 0. Otherwise, there goes your function. All you've got is 0 plus k. Right, so a and b are never 0, but they can be 1. H and k can be 0 if they don't exist. All right, so let's identify a, vertically stretched by a factor of 2, reflected across the x-axis. A is going to be negative 2. Let's see if we see any type of horizontal stretching or compressing or reflection over the y-axis. Nothing about any of those things. That means b is 1. About h. H is our horizontal translation. Doesn't say anything about right and left. So that means h is 0. But we do have a vertical translation. It's 1 up. So k is going to be positive 1. So now what we have to do is plug in. So f of x equals negative 2 times the square root of, now you don't have to put 1x. And you don't have to put parentheses if b is 1. You never have to put parentheses if b is 1, right? There's no point in having 1 times, because it's not going to change it. You certainly could put parentheses, but you don't have to. We can just put the x there. Right? Since h is 0, we don't really need a minus 0, but we do add the plus 1. So there's our equation. F of x equals negative 2 times the square root of x plus 1. Right? And all we're doing is, maybe I better make that clear, our general equation. So I'm just going to put the general equation above it, just to make sure that everybody knows why I put each number where I did. Right? So this is our general equation. F of x equals a times the square root. That's an a. It looks like a 9. a times the square root of b times x minus h in parentheses, and then plus k. All right, so the h already was 0, so I didn't really need an x minus 0. And the b was 1. I really don't need 1 times x minus 0. But we do need the a and the k. All right? And there's our equation. And if you have any trouble, you can let me know in class. Let's do another one. And so same thing. This time we don't have spaces. We'll just write them we'll just write everything down. All right, so we want to use the description to write the square root function g. The parent function f of x equals the square root of x is reflected across the x-axis. And underlining? Well, maybe that will come up. Compressed vertically by a factor of 1/5 and translated down 5 units. All right, so now let's write our equation. Excuse me. All right, so let's think about how each of these things affects our function. So if we have a reflection across the x-axis, then A is negative. Also, we have a vertical compression. And the factor is 1/5. And so with vertical stretches or compressions, so A is equal to the factor. And it doesn't matter whether it's a vertical stretch or a compression. So A is equal to the factor. B is a little different. We'll talk about B in probably the next problem. All right, and then we're translated down 5 units. All right, so let's just remember our general form. F of x, actually, yeah, we'll do f of x, but I think it said g of x somewhere. Yeah, it said our function g. I don't remember the last one was g or what. So we'll just call it g of x, I suppose, on this one. So g of x equals a times the square root of b times x minus h plus k. All right, and so now let's identify everything. All right, so we want to identify A, B, and then H and K. All right, so since A is reflected across the x-axis and vertically compressed by a factor of 1/5, A is going to be negative 1/5. No horizontal stretch or compression, no reflection across the y-axis, B is just 1. No horizontal translations, not like the last problem. And we are we're translated down 5, so K is going to be negative 5. So now we can just plug in the values. So G of x is equal to negative 1/5. The square root, no reason to put the 1 there, and you don't need the parentheses because you've just got x under the radical, and then you have a minus 5. And make sure the minus 5 is not under the radical. If you have trouble with that, sometimes it's hard to make your radical end and then try and make sure you have enough space here. You could, by the way, write it like this. You could write g of x equals, come on, negative 5, because 5 is negative, and then 1/5 is negative 2, minus 1/5 square root of x. Either is fine. They are the same equation. So if the order is ever changed, it's still the same equation. Commutative property, you can change the order you add things in. And technically that is addition, right? We're adding a negative 1/5. All right, let's do another one. I don't have too many of these. I think I maybe have 4. The parent function is times the cube root of x. Really nothing else is going to be different except got to put a little index, a little 3 for the index on the radical, is vertically stretched by a factor of 3, reflected over the y-axis, translated 4 units to the left, and 2 units up. Ooh, tricky, tricky, tricky. All right. So let's do this one. All right, so let's identify all of our important things. Vertically stretched by a factor of 3. I'm just going to underline everything that's important. Reflected, and it's going to be everything that happens to our function. Reflected over the y-axis, and then we can fill in the a, b, h, and k. Translated 4 units to the left, direction is important, and 2 units up. All right, so remember our format. I'll just call it f of x. I guess I'll call it h of x. Call it anything you want. I didn't specify. F of x equals a times, it's just the cube root now, of b times, don't forget your parentheses, x minus h, and then plus k. All right, so let's identify everything. All right, so we have a, b, h, k. All right, so A, we have a reflection over the y-axis. Oh, does that affect A? We have a reflection over the y-axis. All right, remember, is that A? We've had so many reflections across the x-axis. Let's go back to that page two pages ago. So A is reflection over the x-axis, B is reflection over the y-axis. So that reflection has no impact on A whatsoever. The only thing that does have an impact on A is the stretching, the vertical stretching. Right? So A is 3 because it's vertically stretched by a factor of 3. B is reflected over the y-axis. That means B is -1. There's no horizontal stretching or compression. Right? There's just the reflection over the y-axis, so B is -1. 4 units to the left, that means H is -4. And 2 units up, K is positive. Plug in our values here. All right, so we have f of x equals 3. Now, the tricky part here is going to be in the parentheses there, but actually it won't be too tricky when we remember our parentheses. Okay, so super easy if you remember the parentheses. Right? It's a little hard if you forget the parentheses. All right, so B here is -1. All right, so then we have our parentheses, and we have x minus a -4. So we need to simplify that. And then plus 2. So f of x is equal to 3 times the cube root. We don't have to put a -1. We could just put a negative. So we need these parentheses because then it's going to be x plus 4. Do you see why we need the parentheses? Because we have some parentheses there. All right, so without parentheses, then it would be, there's the rest of my word. It would be f of x equals 3 times the cube root of, and then we'd have to remember it's -x minus 4. And now you're going to think, oh, it goes to the right. But no, it doesn't go to the right, even though we have a -4. Right? It doesn't go to the right because we have distributed b to both terms. Right? So without parentheses is that. But then we have to remember, if we want to find our translation, the translation's not -4. Right? You got to factor out b from both terms. To find what h really is, right? But you don't have to worry about it if you just remember the parentheses. right? Just put, then it's just the way you think of it, right? X minus h, right? That's just the same we've been doing, right? When b was 1, right, we didn't worry about the b at all, right? So we don't have to worry about the b either here. Just keep your parentheses, and then plus 4 is 4 to the left, just like it always is, right? So just always leave those parentheses on, and then you can just plug into your values, and you don't have to worry about b. You just have to plug it in, all right? So this one's a little tricky, a little bit trickier than the other ones, but if you just remember to use your general formula, don't remember all your pieces, right? And you think about how each thing affects your function, you'll do fine. Let's see, do I have another one, or was that the last one? I think this is the last one. So parent function y equals the square root of x is reflected over the x-axis and horizontally stretched by a factor of 3. And I tried to keep the things happening in this one to a minimum because this one is a little trickier. And so I didn't put any translations with it. Reflected over the x-axis, horizontally stretched by a factor of 3. All right, so our equation, remember, will be f of x equals, this time it's the square root, but it won't be any different, square root, cube root, a times the square root b times x minus h plus k. Right? Plugging in will be exactly the same, just the index on the radical changes. The graph is different, but in terms of writing it's not much different. So we identify a, b, h, k. I already kind of gave b, h and k away. I said I tried to keep this one not too complicated because we have some tougher things to deal with than this one. And there's no translation. So notice we're just reflected and stretched. No translation. Right? We're not going up and down. We're not going right and left. It means h and k are 0. All right, so let's think about a and b. All right, so let's do a first, and then we'll talk about b. So we are reflected over the x-axis. That means a is negative. Is there a vertical stretch or compression? Why, no, Ms. Bashagman, there's not. There's just a horizontal. So a is negative 1. Now b is not 3. So for the a is equal to whatever the factor of the vertical stretch compression is. Not so for b. So to find the b, right? To find out what our b is, we take our horizontal stretch or compression, and that factor there, and we take that factor and we put it over 1, and that's what b is equal to. All right, so b is 1 over your horizontal stretch or compression. A is just your vertical stretch compression factor. All right, so why is it 1 over? All right, because it's going to have a different relationship. Right, because now I'm multiplying it by x. Right, before I was just affecting the results. Right, so if I take a number and I multiply it by a number greater than 1, of course it gets bigger. And if I take a number and I multiply it by something between 0 and 1, of course it's going to get smaller. But if it's inside that radical, so now I'm taking the square root of b times x to get to some value. Right? So if my b is greater than 1, right, it's going to end up being a horizontal compression because I'm going to get to each value faster, right? Because x is growing, not y. So the function's not growing. I'm just getting bigger results for smaller and smaller x values. Right? And if it's compressed, right, if the scale factor is between 0 and 1, then it's vertically stretched because it's going to take a larger x value to get to the same point. So because it's affecting x, we need a smaller x value or a larger x value? If we're stretched by a factor of 3, it means we're going to need a larger x value because our b is equal to 1/3. right? So that's what's causing it to stretch horizontally. That b is between 0 and 1. I need a bigger number just to get to the same number under the radical. So I get to the same y value, right? So b is 1 over your horizontal stretch compression factor. And if you look at a lot of the graphs and you start graphing them and you see if you've got a number between 0 and 1, oh, it just takes forever to get to the next x, to get to the next y value. X has to be so big, right? But if you've got a number that's greater than 1, x grows so fast, right? We're getting to the next y values really, really quickly. So now all you gotta do is plug into our equation. So now you can see why I didn't do a horizontal translation or a vertical translation. I kept it nice and simple because we had a little bit trickier b here. So we have negative, because a is -1, and then we have the square root, and we don't need the parentheses now because it's only 1/3 x, right? There's nothing else there, right? Whether I put parentheses around x or not, it's still 1/3 times x. I think this is the last one from the description, and then we go to the graph. So I'm going to end this podcast, and I'll see you in the graphing podcast. Bye for now.